Hello students, welcome to Topper's Tool channel. In this session, we will discuss linear differential equations. So what do you mean by linear differential equation and what are the methods to solve linear differential equation? Students, see here, any differential equation of this form, for example, like this, with constant coefficients I'm discussing. So a naught d power ny by dx power n plus a1 g power n minus 1 y by dx power n minus 1 plus a2 d power n minus 2 y by dx power n minus 2 plus so on. A n y is equals to some function of x, say phi of x. Differential equations of this form are called linear differential equations of order n. So we also represent this in the form a naught d power n plus a1 d power n minus 1 plus a2 d power n minus 2 plus an and y common as it is equals to phi of x. Means I have taken this capital D as d by dx. So the differential equation 1 can be put in another form second, that is a naught d power n plus a1 d power n minus 1 plus a2 d power n minus 2 plus an and y is common, phi of x. In short, linear differential equations can also be written in the form f of d into y equals to phi of x, where this f of d stands for, it is this part, coefficient of y expression. This expression is called f of d. So linear differential equations will be in general in the form f of d into y is equal to phi of x. And now we come across two types of linear differential equation. One is homogeneous linear differential equation and another is non-homogeneous linear differential equation. So if the right hand side function is 0, means if phi of x is 0, then this equation 3, then 3 is called homogeneous linear differential equation. And if phi of x is not equal to 0, means if it's any function of x, then equation 3 is called non-homogeneous linear differential equation. So remember, homogeneous means right hand side used to be a function of no function of x, means you will find only 0, and if there exists any function of x, that equation is called non-homogeneous linear differential equation. Now we will discuss how to find solution of linear differential equation. Now see here, suppose you are given this. So we'll discuss solution of homogeneous linear differential equation. So what are the steps involved in finding the solution? Suppose if you are given this equation, f of d into y is equal to 0, means right hand side is 0. So its solution is given by y is equal to complementary function. The solution of any homogeneous differential is equals to y is equal to complementary function, and that is denoted by yc. So what do you mean by complementary function and how to find? So how to find complementary function? So to find complementary function, yc, first you need to write an equation called auxiliary equation. Step 1, write auxiliary equation. Write auxiliary equation. In short, we write it as AE. Write auxiliary equation as f of m is equal to 0. Means whatever the coefficient part of y, in that you replace d as m and equate it to 0. Okay, we'll understand in the next stage when you solve one example. Step 2, find the roots of auxiliary equation. Okay, you have to solve this equation for m. You will get various roots, and depending on the nature of the roots, you need to write complementary function. Step 3, depending on the nature of roots, write yc as below. So here I'll be giving one table. According to that, you need to write complementary function. Okay. So what you need to do is, first say here are the roots. Nature of roots I can write. Okay. So if the roots are distinct, say if you got roots as distinct, C1, C2, C3. Suppose if you get distinct roots, all roots are different, then your complementary function yc you have to write in this form: C1 e power, or I can write, if the roots are say C1, I'll change it. Say if the roots are m1, m2, m3. Say if the roots are m1, m2, m3 distinct. So complementary function you have to write c1 e power m1x, c2 e power m2x plus c3 e power m3x. Okay. So if the roots are m1, m2, m3, you have to write c1 e power m1x, c2 e power m2x plus c3 e power m3x. Suppose if the roots are repeated, so if you got m as the root as m twice, so you need to write yc as c1 plus c2x e power mx. Suppose if you have roots like this, m1 is repeated twice, means m1 m1 twice root, and another root is m2. In such case, you have to write yc is equal to c1 plus c2x into e power m1x plus c3 e power m2. So in this way it continues. If the roots are distinct, you have to write distinct terms. If the roots are repeated, you have to write the expression, that's polynomial c1 plus c2x e power mx. Suppose if the root is repeated 3 times, means if you have m repeated 3 times, then yc you have to write, complementary function you have to write c1 plus c2x plus c3x square e power mx. Okay, so this is for real roots. If the roots are, say, complex, means suppose if you got roots as this alpha plus or minus beta I. If the roots are complex, then yc you have to write e power, this real part, alpha x into c1 cos beta x plus c2 sin beta x. In this way I have to write. If the roots are, say, alpha plus or minus beta I, complementary function you have to write e power alpha x, means e power this real part into c1 cos beta x plus c2 sin beta x. For example, look at this. If you have roots like this, 2 plus or minus 3i, then yc is e power 2x into c1 cos 3x plus c2 sin 3x. If the roots are simply plus or minus 2i, means here real part is 0, so e power 0 is 1, so I can write only this c1 cos 2x plus c2 sin 2x. Suppose the roots are like this, 3 plus or minus 2i, these are complex, and another 2 are real and distinct, say like this. There are totally 4 roots, 2 are complex and 2 are real and distinct. In this case, you have to write your complementary function yc as, okay, for real roots 4 and 6, you may write c1 e power 4x C2 e power 6x, and for the complex pair C1, that is 3 plus or minus 2i, you need to write e power 3x into constant, third constant C3 cos 2x plus C4 sin 2x. So in this way you have to write. And the last one, if the roots are repeated complex, if the complex roots are repeated, for example, if you come across like this, alpha plus or minus beta I, and another pair is also alpha plus or minus beta I. So repeated complex roots. So YC you need to write e power alpha x, and coefficient of cos and sine you have to write linear expression C1 plus C2x into cos beta x plus C3 plus C4x into sine beta x. So in this way you need to write complementary function. If it is homogeneous, then general solution is its y is equal to yc. Okay, so this is the general solution of homogeneous linear differential equation. So remember this. We will solve some examples. Look at this. Solve d square minus 5d plus 6 into y equals to 0. So first you need to write auxiliary equation. Auxiliary equation means you have to equate this coefficient of y power to 0 by replacing d as m. So you need to write m square minus 5m plus 6 equals to 0. So solving this quadratic equation by any method, factorization or use your calculator. So splitting this 6, factorization, one can write directly. So 3, 2, minus 3 minus 2, sum is minus 5 and the product is plus 6. So minus 3m minus 2m plus 6 equal to 0. Factorize this, m common, m minus 3 and minus 2 common from the last two terms. Again it is m minus 3 equal to 0, and that gives you m minus 3 common, m minus 2 remains. So this gives you, solving this, m is equal to 3 and m is equals to 2. So these are the two distinct roots. Therefore your general solution, it is being homogeneous, your general solution y is equal to yc, and yc you are right. These are two distinct roots. So c1 e power 2x plus c2 e power 3x. So this is the complementary function for the given differential equation. See another example. Suppose you are asked this. Solve d square minus 6d plus 9 into y equal to 0. It is not 6x, it is 6d. Yes. So auxiliary equation is, auxiliary equation for this differential equation. So m square minus 6m plus 9 equal to 0. Solve this. So this is perfect square. The factors are m minus 3, m minus 3. Okay, because if you split 9, if you break 9 as 3 into 3 is 9 and minus 3 minus 3, their addition is minus 6. So this gives you m equals to 3 and 3. So these are the repeated roots. So therefore the solution y is equal to complementary function yc, and which is nothing but roots are real and equal. So repeated c1 plus c2x repeated twice. So c1 plus c2x into e power this root 3x. Look at another example. Solve d square plus d plus 1 into y equals to 0. So here auxiliary equation is m square plus m plus 1 equal to 0. So this is clearly non-factorizable. So you can use this formula, m equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So here a is 1, b is 1, c is 1. So you can write minus 1 plus or minus b square is also 1 minus 4 into 1 into 1, that is 4, divided by 2 into 1 is 2. Okay, so because here a is 1, b is 1, c is 1, coefficient of m square m 1 respectively. So this gives you minus 1 plus or minus square root of minus 3 divided by 2, which gives you minus 1 plus or minus square root of minus 3, that is root 3 into I, divided by 2 means I can write like this. So this is of the form, these are complex roots. So here alpha is minus 1 by 2 and beta is root 3 by 2. So clearly your general solution y is equal to yc. So this is the general solution. So that gives you e power alpha x. Alpha means minus 1 by 2x into c1 cos root 3 by 2x plus c2 sine root 3 by 2. So this is how you can write complementary function from known roots. Now see here, take another example. Suppose this is the question to be solved. Solve d square minus, that is d cube minus 3d square plus 3d minus 1 into y equals to 0. So here auxiliary equation is m cube minus 3m square plus 3m minus 1 equals to 0. So this is very easily factorizable. So if you take m square common from the first two, so you're left with m minus 3. From the next two, if you take 1 common, you will remain with, let me do it once again. So we'll do it in another way by synthetic division. So first, when you get a auxiliary equation of higher degree like m cube, m power 4, so on, you need to find roots by the method called synthetic division. So first, there is a one test called addition of coefficients. Now see here, if sum of the coefficients is 0, so here sum of the coefficients 1 minus 3 plus 3 minus 1. If we add this, sum of the coefficients is 0. So if the sum of the coefficients is 0, this implies m equal to 1 satisfies this equation. Means m equal to 1 is the root. So you got one root of this equation by this, what we call it as by inspection. So if the sum of the coefficients is 0, then m equal to 1 is the root. So if you got one root, then other roots can be found by synthetic division. So what you need to write is, you write the coefficients, that is 1, minus 3, 3 and 1. Okay. So whatever you got this root as 1, so you got the root m equal to 1. So you take that root 1 here and bring this number as it is 1 and go on multiplying. 1 into 1, 1. So minus 3, 1 is minus 2. Add them. Minus 2 into 1, minus 2. Add this. You will get 1. 3 minus 2. 1 into 1, 1. And their addition gives you 0. Okay. So if you get this place 0, last place, then definitely this is the root. Again look at the coefficients. So this is the reduced equation 1 minus 2, 1. So if you add these numbers, if you get again 0, so 1 plus 1, 2, 2 minus 2 is 0. So if the sum of these numbers is again 0, then again 1 is going to be one more root. So by inspection we call it as, so bring this number as it is, 1 into 1, 1. It's minus 1, minus 1 into 1, minus 1, and this is 0. Now again look here, 1 minus 1, their addition is 0. So again one more time 1 is going to be the root. So bring this number as it is. So 1 into 1 is 1 and this is 0. So it is cubic equation and the three roots are 1, 1. So therefore 1, 1, 1 are the roots of the auxiliary equation. So 3 repeated roots. So therefore general solution is y is equal to yc, and that is, it is c1 plus c2x plus c3x square into e power this 1x, number 1x. Yes. Let's move on to another example. Solve m cube plus m square plus m plus 1, sorry, solve d square plus d, it's d cube plus d square plus d plus 1 into y equal to 0. So auxiliary equation m cube plus m square plus m plus 1 equal to 0. This, either you factorize this, if you factorize taking m square common, m plus 1, from the next two, take 1 common, m plus 1 equal to 0. So taking m plus 1 common, it is m square plus 1. This gives you m plus 1 equal to 0, m square plus 1 equal to 0, m equal to minus 1, m square equal to minus 1. So that is m is plus or minus under root minus 1, that is plus or minus I you will get. So therefore, roots are here, two complex conjugates plus or minus I and one is minus 1. So your general solution is y is equal to yc. So yc is for this real distinct root, that is I can write c1 e power minus x plus for these complex I can write c2 cos x plus c3 sin x. So this is how you can write complementary function for any given differential equation. In the next session, we will discuss how to solve non-homogeneous linear differential equations. So if you like, please do subscribe to the channel and hit the like button. So take care and watch the next session.